Alright, in this video I'm going to run through the questions that you need for CC1, CC2 revision, and then SC22, which is the topic that we are starting after Christmas. CC1 and CC2, I mean, you would have done it in year 9, it's like states of matter and separating mixtures, but don't, even though the content's not difficult, they can ask some tricky exam questions on it, so don't overlook it. First question here is on chromatography, and it wasn't an easy one. They asked you to calculate the RF value, which should be okay. RF is a distance moved by the spot divided by the distance of the solvent. The spot in question is the one that's present in X and Y, so it's this spot here because it's at the same level and it's from X and Y. Distance moved by spot, if you use this ruler, is 3.9. The solvent front is here at 6.5. You divide and you get your answer as 0.6. But the next question they ask is, how can you get a more accurate RF value? And this is really badly answered that year. To get a more accurate RF value, you're going to need a longer piece of paper, because a longer piece of paper will give you a better separation of the different substances and therefore a better RF value. Like a spot up here, there's no more room, okay? There could be some spots that haven't separated out yet, but if there's no more room, you just have to end the experiment. If you had a much longer piece of paper, then every spot gets the chance to fully separate out. And that's your only acceptable answer, is using a longer piece of paper. They then ask you about this spot here, why it stays on the start line, and they ask you what you can do to change that. You need to know why it's staying on the start line. It's staying on the start line because it's not dissolving in the solvent that you've used. You therefore need to change the solvent and find one where it will dissolve. So you're going to use a different solvent so that Y will dissolve. It's for 2 marks. You get 1 for saying different solvent, and the second for explaining why, because you're asked to explain that change. You want Y to dissolve so that it can move up the paper. The next question, again, not necessarily the easiest one. It's about a heating curve, and it's just about state changes, which should be pretty straightforward. Okay, you can see that you've got temperature on the y-axis, so you're heating your substance, and between B and C is when the substance melts. If it's melting after being heated, then originally it was a solid, and then after you melt it, it's going to be a liquid. And you're asked to explain the shape of the graph, so you're going to have to explain why that graph is flat between B and C in terms of the changes of the movement and the arrangements of the particles. So I started off by talking about between A and B, that it's a solid, and I'm talking about the movement and arrangement of the particles when it's in solid form. I've drawn a solid here. We can see that the particles are in nice, neat layers, regularly arranged. In terms of movement, they can only vibrate, but as you are heating this solid, what changes are happening? Well, yes, they can only vibrate as a solid, but the more you heat it, and the more energy the particles have, the more they will vibrate. So they will start to vibrate more. Okay, so I've written in here, particles are arranged in fixed position in neat layers. You can phrase that however you want to. They can only vibrate, yes, because it's a solid, but they will start to vibrate more as that temperature is increasing. So make sure you're mentioning how that movement is changing as you're increasing the temperature. Between B and C, you'll notice the graph is flat when it's actually melting, and that means that when you're heating, when that substance is actually melting, it doesn't increase in temperature. So here the solid is getting hotter and hotter and hotter and hotter, and now the temperature is staying constant. That doesn't mean that you've stopped heating it, you haven't. But at this point, all of the heat energy that you're putting in goes towards breaking the bonds between the particles to turn it from a solid into a liquid. Because all of the heat energy is focused on breaking the bonds between the particles, the heat energy is not being used to raise the temperature of the substance, and the temperature of the substance remains constant at that time. So you are still heating it, it's just not getting hotter because that heat energy is used to separate particles. So I've written that here, the particles are using the energy to break the bonds. When they break those bonds, it's becoming a liquid, so they're going to become randomly arranged instead of being in fixed positions. There's no increase in temperature at that time, as all of the energy is being used to separate the parts. So I should add, there's no increase in temperature of the substance. It's not that you're not heating it anymore, you are, but the substance isn't increasing in temperature because the energy is being used to separate the particles. So once you've done that between C and D, now you've got it as a liquid. So in terms of the movement as a liquid, they can move freely in those fixed positions, move freely, and as you're heating them, they're going to move faster and faster, and then the arrangement, they are still touching, but they are randomly arranged. Okay, so touching but randomly arranged, they're moving freely and they're moving faster as the temperature increases. So you need to mention the 3 different sections in terms of movement, in terms of arrangement of particles, and make sure you're talking about how it is changing. Question 3, it's all about the purification of water. This comes up in CC2. Potable means drinkable. It does not mean pure. Tap water contains minerals, yet it is still drinkable. As long as those impurities are harmless, the water is safe to drink, therefore it is potable. To purify water, you've got these 3 processes. Sedimentation is this one. You basically just put the water in a big tank, you let all the solid bits settle to the bottom. Why do you have to filter wastewater? You're trying to remove insoluble solids. If you look at the mark scheme for this one, you can suggest the name of a solid you might be removing, such as sand, but they're not going to allow you to suggest anything bigger like twigs or branches or plastic bags, because those things are removed in the screening process before you get to filtration. So it's only small insoluble solids. Why do you chlorinate? Chlorine kills microorganisms or kills bacteria. The other side, you've got 2 liquids that are mixed together. They've got different boiling points. How are you going to separate them? You're going to use distillation. You can say simple or fractional, or just distillation itself. How does that process work? You heat them both. Nickel tetracarbonyl will evaporate first because it's got a lower boiling point. After you've evaporated it off, you can cool it and condense it. Your other one, iron pentacarbonyl, will just stay in liquid form as long as you don't heat it up to 103 degrees. The next one here again is on distillation. You've got seawater, which is salt and water. You're trying to separate the salt from the water, but keep the water. You don't just want it to evaporate off, you want it at the end. So you're heating. What's going to happen is that water will evaporate, the water vapor will rise, it will enter this tube, it will cool, it will condense, and then you can collect it. The salt is going to have a really high boiling point because it's an ionic compound, therefore it is not going to evaporate, it will stay in your flask. And the next question asks how you can improve this process. I've marked this question before. A lot of students suggest putting like a seal here so that the water couldn't escape. Remember, it's condensing in this tube, but when it's coming out of this tube, it's coming out as a water, it's not coming out as a gas, so it's not going to escape out the sides. And if you put a seal there, you're going to have a closed system and you're heating it, the pressure can build up and it can explode. So you're not going to put a seal in. Instead, you want to make this tube colder so that the condensing process is more efficient. So you're going to add a condenser, which will keep this tube cold. And that will speed up the condensing process. So you add the condenser, why? To cool the tube and makes condensation more efficient. The next one, number 7, another little multiple choice. The answer for this one is going to be C. Okay, you want it to still be solid at 20 degrees. This one doesn't melt until 30, so it will be solid at 20, but you do want it to melt by 80. Well, as soon as you heat it above 30, it's going to melt, therefore the answer is C. The next few questions are on hydrocarbons, so you would have done this in CC16, nothing is new here. You've got a sample of ethene, they tell you is C2H4. You are going to burn it completely in oxygen, so it's a combustion reaction. Because you're burning it completely, it's going to be complete combustion. Your products are CO2 and H2O. You then need to balance it. Balance the carbons first. 2 carbons on the left, I want 2 carbons on the right. 4 hydrogens, I want 4 hydrogens. That gives me, in terms of oxygen, 2 times 2 is 4 oxygens here from the CO2, and I've got 2 oxygens there from the H2O. 6 oxygens in total means I need a big 3 in front of the O2. You get 3 marks for doing that. 1 mark for having the left hand side right, 1 for the right, and 1 for having it balanced. But you only get the balancing mark if the equation is correct. Hexene is an alkene that contains 6 carbon atoms. Give the molecular formula. You need to know your general formula for an alkene, which, oh no, it's not that, it's CnH2n. So if I've got 6 carbons, I must have 12 hydrogens, exactly double. If you got really stuck and you weren't sure what the general formula was, you had a mind blank, but you know that an alkene has 6 carbons and you know that it must have a double bond, just draw out 6 carbons in a line, put a double bond someplace, and then fill in the hydrogens. Each carbon has to have 4 bonds, so this carbon can only have 2 hydrogens. This one already has 3, so it can only fit 1. This one can have 2, can have 2, can have 2, can have 3, and if I add up all my hydrogens, I should get 6, 7, 8, 9, 10, 11, 12, okay? So I can use that to figure out how many hydrogens if I'm having a complete mind blank and can't remember general formula, provided that they give you a small number of carbons. Obviously, if they tell you you've got 40, it would take you ages to do it that way. Explain why ethene is an unsaturated hydrocarbon. There's two parts to this. Why is it unsaturated? Why is it a hydrocarbon? It's a hydrocarbon because it contains carbon and hydrogen only. It's unsaturated because it contains at least one double or triple bond. In this case, it contains a double bond between the two carbon atoms. The last one here is on molecular formula. This is where we have to go through 3 steps. In step 1, you take the empirical formula and you get the relative formula mass. So I'm going to get the formula mass of CH2. Carbon is 12, hydrogen is 1, you've got 2 hydrogens, the formula mass of CH2 is 14. In step 2, you take the number they give you in the question, which is 84, and you divide it by your answer to step 1. So 84 divided by 14, I should really be able to do this in my head, I think it's 6. Is it 6? It is 6. It is 6. And then in step 3, you take your empirical formula, CH2, you multiply it by your answer to step 2, so it's CH2 times 6. 6 times carbon is C6, 6 times 2 is 12. So it's an alkene with the molecular formula C6H12. Again, if you know those 3 steps, that is a very simple calculation, but make sure you do know how to do it.